Okay, number 3. We're going to find the location on the x-axis. So here is an x-axis where I can put a charge of negative 8 times 10 to the 6. So I want to put a charge of negative 8 times 10 to the negative 6 coulombs. And so I can place it so there's no net force. So I want the summation of force on this charge to equal 0. The magnitude of Q1, which is at the origin, so we'll call this our origin. So here's where Q1 is going to be. And this is negative 6.5 times 10 to the negative 6 coulombs. And the charge, magnitude of charge 2 at negative 0.4. So if this is my 0 point, which is the axis, right here will be Q2. This would be 0.4 meters away. And that charge is negative 4.2 times 10 to the negative 6 coulombs. Okay. So looking at this, here's what we know. This is a force problem. This is a force electric problem using Coulomb's law. Well, Coulomb's law says the force is equal to K times charge 1 times charge 2 over R squared, the distance between them squared. Now, I want to put both in there. So let's look at this. Being negative and negative, where can I put a charge so it's going to cancel out? If I put a charge out here of this negative 8, this is being my it's a negative charge. Let me get negative. My negative 8 charge. Well, this negative negative is going to cause it to repel. That's the force of the 6.5. And the force of the 4 is going to cause this to move this way. These don't have a chance to cancel, so it cannot go on the outside. It cannot go on the outside on this side for the exact same reason, which means if I put this in the middle here, if I put my negative 8 place charge, the negative 4 is going to cause it to move this way. That's because of the force of the 4. And the 6 is going to move it this way. That is going to give me an option of them canceling out. Now, because this is bigger, I also know that this is going to be the shorter distance, and I'm going to call that x, which means this distance here is simply going to be the entire distance, 0.4, minus that x distance to the charge. So, I want the summation of force to equal 0. I have a force due to the negative 6.5 times 10 to the negative 6. I have a force of the negative 4.2, and this is equal to 0. They are going to be pointing in opposite directions, so one of them needs to be negative, one needs to be positive. And therefore, the force of the negative 6.5 is going to need to equal the force of the negative 4.2. Cool. With that information, I now can take my next step, which is plug in my Coulomb's law work for it. So the force of the 6.5 will be K, which is 9 times 10 to the 9. Q, which is simply the negative 6.5 times 10 to the negative 6. My test charge, which we can just say the test charge, or you could put in negative 8.6 times 10 to the negative 6. All over the distance, and the distance to the negative 6.51, which is here, is negative, not negative, 0.4 minus x, so I want a negative, and that's squared. Okay. On the other side here, I will put my other force due to the 4.2. So this would be 9 times 10 to the 9, 4.2 times 10 to the negative 6, and the test charge. All over x squared, because the distance between here and here is x. I don't like x's on different sides. I also have a preference. I like this messier term to be brought to the top. So I'm going to multiply both sides by 0.4 minus x squared, and that will give me 0.4 minus x squared over x squared. Now I'm going to bring this over to have all numbers on the same side, giving me the same top over 9 times 10 to the 9 negative 4.2 times 10 to the negative 6, and my test charge. Well, a couple things I should note right now. Number one, this formula is absolute value of the charge, so the negative I put here doesn't matter even if I include it over there. So I can get rid of these. I can then cross out these, they divide themselves. I can cross out my test charge. That's why this value of my test charge didn't matter. I also can go so far as cross out these times 10, and what I get is 6.5 divided by 4.2 is equal to 0.4 minus x squared over x squared. Now before you jump into more complicated math, realize square term number. Square root both sides. Make it easy on yourself. So let's do that. So 6.5 divided by 4.2, and then square root that answer, gives me, I'll work it over here, so think 1.24 equals 0.4 minus x over x. Multiply x over 1.24x equals 0.4 minus x. Now I want to bring this x over. 2.24x equals 0.4. X equals 0.178 or 8 meters. This is the distance of x, so it's the distance from the 4.2. So this is east of the negative 4.2 times 10 to the negative 6 Coulomb charge. If I don't ask you from which one, I will take either. If I specifically ask from the 4.2, this would be your answer. If I ask from the 6.5, you would then have to do 0.4 minus 1.8 to get the distance from the 6.5. That's it. There are some other shortcuts. You didn't have to put 99. They cross themselves out. But I do want to see the basic formation of your work. Good luck.